This is the first vector video, and you'll see when we do the resultant vector video why we're doing vectors in this quadrilateral unit, but I'll save that for the second video. This video is all about the basics of vectors, so we can discuss, do more with them, and do all the fun stuff. So first of all, what is a vector? All we mean by a vector is it has two components. It has a magnitude, so it has size. How long is an arrow? So I always think of a vector as an arrow. And that arrow is showing both direction and size. So if I drew a smaller arrow in the same direction, that would mean it means something different. It means I didn't go as far in that direction, versus this one that was really long meant I went further in that direction. So vectors are used all the time in physics for forces, and you'll see some examples in the second video. But here's some basic ones, like if a car heads west, that's a vector. It's showing that it's a direction and then how far did the car go. Or a hiker walks south at 5 miles per hour, so we could figure out that he was going south and that was his speed. Or the wind blows at 45 miles per hour. So then there are two ways we can describe a vector. So we can indicate the magnitude and direction in two different ways. So we can do by size and directions. So that would be like if I gave you the size, let's say it was 40 meters, and then I gave you an angle at 180 degrees. That's one way to write that. And notice that I'm using these pointy brackets. Vectors always have these pointy brackets, just so we don't get them confused with coordinate points. And then we could also do by a horizontal and vertical change. This looks like translations that we've been doing, that we did in the translation unit first semester. So I could say, okay, first we did a horizontal movement of 12 meters and then a vertical movement of 16 meters. That's another way to describe that vector. So let's just get used to drawing vectors and calculating magnitude and direction and so forth. So on your vectors notes, you have these examples. We're going to sketch them. So if I wanted to sketch 20 meters and 42 degrees, let's talk about the degrees portion. I know we can estimate how much 20 meters is, but 42 degrees, since we're doing this on a coordinate grid, we need to get some ground rules stated. So this x-axis going in the positive direction, we're going to always call that 0 degrees. And the vertex of our angle is always at the origin. And then if we go counterclockwise, this would be 90 degrees. This would be 180 degrees. And then this would be 270 degrees. And then all the way back around would be, again, 360. And I believe we talked about this in the transformation unit, but in case you forgot, I wanted to make sure we were clear on that. So if I wanted to go 42 degrees, that would be somewhere in this first quadrant between 0 and 90. So let's just estimate that it's like that. And I'm going to estimate where I think 20 degrees in that direction would be. So I'm going to call this 20 meters. And then I would show that what the angle was by doing this. I do a little arc so it looks like I rotated that, and I'm going to put 42 degrees. So that's how we could sketch that. Let's do the next one. So 10 meters at 310. So 310 means I'm going to start here at 0 and go all the way around until 310 is basically 50 degrees shy of 360. So I'm going to go all the way here. And then it's only 10, so I shouldn't make it as long as that blue one. It should be half that size. So this is 10 meters, and then that is 310 degrees. There's degrees. All right, so you see how that red loop shows that that's the 310 degrees. And then I also have 40 meters at 175 degrees. So 175 degrees is 5 degrees short of 180. So I would start here and go all the way around to just about here. and that's 40, so I want to make it twice as long as that blue arrow. So that's going to be the 40 meters. Okay, so that's just estimating and sketching. It's very important that you know how to sketch a vector because we will be using vectors to solve different problems. So it's important you get this down. If you have questions about this, please ask about it in class. All right, so then how do we find that on the next part of your notes, we're going to be calculating the horizontal and vertical change of each of these vectors. So how do we find these vertical and horizontal components? Well, if I have a vector drawn, like I do here, it says 60 and then it's at 73 degrees. All right, so all I'm going to be doing is dropping from the very tip of that arrow, just drop a vertical line down to that horizontal line. So you see how it makes a right angle. So it's where the horizontal and the vertical meet. And now this looks like a right triangle, and we can solve for these sides. We did trig in the last unit, and if you don't remember the trig, go back and look at all of those trig videos from last unit. All right, so we can use SOHCAHTOA to help us find those sides. So I would just be doing, for example, to find y, that would be the opposite of 73. So I would be doing sine of 73 equals y over my hypotenuse, which is 60. Okay, to do the x, I would be doing cosine, right? Cosine of 73 equals x over 60. And then you guys can solve from there. Okay, so that's what we'll be doing for our vectors that we just did. Okay, so our 20 meters at 42 degrees, we said we would drop a vertical line down. And again, I don't know that I drew that to scale, so I'm going to purposely not draw that on the grid because I don't want you relying on that and saying, oh, it's 15. Well, it may not be exactly 15. Okay, so we're trying to find the y component and the x component. So just like we just did, we said sine of 42 is equal to y over 20. So if we cross multiply, y is going to be equal to 20 times the sine of 42 degrees. So I'm getting about 13.38. So that's how tall that is. That's the vertical component. And then for the horizontal component, for the x, remember we said we were going to do cosine of that angle, and that would be x over 20. So cross multiply, and x is going to be equal to 20 times the cosine of 42. So if you put that in your calculator, you get about 14.86. So yeah, so that's not quite 15 all the way there. So the way we would write that as a vector is we would say the horizontal component is 14.86 and then the vertical component is 13.38. Okay, so I'm going to pause the video. You go ahead and do the same thing for those other vectors. See if you can find the horizontal and vertical change for those. Okay, so I erased the original one just to give myself room. But if we look at the second one for a minute, if you were having trouble with what to do with that 310 degrees, because 310 doesn't fit into a right triangle. So if you're having trouble with that, here's how you get around that. If you draw your 310, you see that we said it was 50 degrees shy of 360. So when you are drawing your vector, you're always doing dropping a vertical line to the x-axis. Okay, so I want to make sure that you're doing that triangle instead of like going over to we don't want to go to the y-axis. Okay, that is not what we want to do. All right, so don't do that. And then make sure that you're using that 50-degree angle. So make sure you're using the angle that goes inside of that triangle. And how do we know that? Well, I know that if I go all the way around, that's 360. So 360 minus 310 is 50. Once you've got that triangle drawn, then it's the same way as we did it before, and I have all my work over here. So notice that I've got x equals 6.43, and then y is about 7.66. But notice in my triangle, x is in the positive direction and y is in the negative direction because the y part went down into the fourth quadrant. So just make sure that you put a negative on that 7.66. Okay, so two things that you got to watch out for. Make sure you know what angle goes in your triangle. Make sure that it goes vertical to the x-axis. And then make sure you're keeping track of, does this go in the positive x direction or negative x direction? In the positive y direction or the negative y direction? All right, so then if we go to that last one, the 40 meters at 175 degrees, again, you want to make sure that you are dropping a vertical line to the x-axis. And notice that 175 degrees does not fit inside that triangle. So how do I know what goes in that triangle? Well, this horizontal line is 180. So 180 minus 75 is that 5 degrees. So that's where I'm getting 5 degrees inside that triangle right there. Okay, and then so you do your math. You get x is equal to 39.85 and y is equal to 3.49, but x is in the negative direction and y is in the positive direction. So make sure to put that negative in front of your 39.85. All right, so now we're going to do the other way of sketching a vector, and that's with those horizontal and vertical components. So it's almost like we're going backwards of what we were just doing. So if we do 12 meters horizontally, so that would be 10, so a little bit past that, so that would be 12 horizontally, and then 16 meters vertically, so that's a little bit past 15. And so where did we end up? So here's where we ended up, and here's where we started. So that would actually be my vector. Okay, actually I'm going to do that in a different color. So the black one is the actual vector, with the red arrows being my horizontal and vertical components. All right, so let's draw the other ones. So I'm going to start the next one in green. So 6 meters horizontally, and then 8 meters, and it says -8, so I'm going to go down. Okay, so then that vector would look like this from the origin to where that ended. So think of this as like when you drive your car. If I go east and then north, that would be like that first one. Whereas the second one, if I went east and then south, that would be like the green one. And then our last one, if I go -40 in the x direction, so 5, 10, 15, 20, 25, 30, 35, 40, so it's way over here. Okay, so -40, and then I'm not going to go vertical at all. So the blue is all that I'm doing. So it's like I'm just heading west. I'm not going north or south at all. So that would be, that blue is also the end result, because if I connect the origin to where that ended up, it's still that same thing. So that would be the vector on that one. So if I want to define magnitude of something, then I'm going to be using Pythagorean theorem, because this just makes a right angle. So if I look back at that first one again, where I had 12 and then the 16, this was 12 meters, this was 16 meters. If I wanted to find how large that was, then I'm going to do Pythagorean theorem. So I'm going to do 12 squared plus 16 squared equals my c squared. So if we do that, that's going to give me, I'm just going to go to the final answer. That would give me 20, exactly. So that's Pythagorean triple, actually. And then now we have to find that, that's the magnitude, we have to find the direction. So how far is that angle? And I'm going to use theta. Remember, that's the Greek letter theta as our angle. So I need to figure out what theta is. Well, we know how to do that too from the last unit, from trig. So I would use these. Again, 20 is a whole number, so we could use that as well, but you won't always get whole numbers. That might be a rounded decimal, so we don't want to use that typically. So I have the opposite side and the adjacent side. So I'm going to set up tan of theta is equal to 16 over 12. And how do I solve that for theta? Anytime we're finding the angle, that's the inverse tangent. And then I'm going to plug in 16 over 12 into my calculator. So if we do that, we get roughly 53.13, and that's degrees. So another way to write that vector would be to say 20 meters, that's the magnitude, and then the direction would be 53.13. So I'm going to pause the video again. Please try the other ones and see if you can get those vectors. Okay, so I erased the first work and put these up. For the third one, I'm going to talk about the third one first. It's a little bit easier. You can't make a triangle out of that since it just headed west, so it's just 40 meters and nothing vertical. So don't try to make an angle out of that. Your vector is just going to be that distance, that's the magnitude of your vector. And then west is 180 degrees, because if I start here and go to there, that's 180 degrees. So there's no triangle for that part. For the middle one, the second one, where we had a vector that was made up of 6 and -8. So if you draw that resulting vector and do the Pythagorean theorem, you get 10. I used a 6, 8, 10 triangle, but you can use Pythagorean theorem as well. Also, make sure that you are doing this angle right here. Okay, so you want to do the angle that's near the origin. Okay, don't do this angle over here. All right, we don't want that. So that theta, we're going to do tan of theta is equal to 8 over 6. And so if I do the inverse, I get 53.13. Now that's the angle that's inside of the triangle, but that's not the angle for the vector. Remember, I have it in here in red. That vector angle goes from all the way here to 0 degrees all the way to that vector. So how do we find that? Well, we're going to take 360 degrees and subtract this angle inside of the triangle. So that's going to give us 306.87. So our final vector value is 10 meters and 306.87 degrees.